and welcome to Algebra II with Mr. Clausen. Today I want to talk with you about solving radical equations. So specifically, I want to go over a variety of examples, but first I want to start talking about solving radical equations that contain a variable. We'll look at certain examples where we're looking at radical equations, but with rational exponents. We'll also talk about radical equations that may contain an extraneous solution, as well as solving equations with two different rational exponents. So to get started, let's just look at a simple radical equation that contains a variable. And one of the things that we need to be able to do is we need to be able to solve for values of x in this given situation. And what you would do, like in an Algebra 1 type context, is you would need to separate out the variable component with the constant components, which are these values here. So to get started with this, what you would do is you would just start separating it out. So for example, if you go -3 and you simplify this out by canceling, and you go like 3 square roots of x equals 12, and then use the division property of equality to get x all by itself, and say that 3 goes into 12 4 times, and then get a situation where the square root of x is equal to 4. We need to be able to separate these components out to a situation like this. And then the only thing that might be a little bit different than what you're used to is that if this is, for example, x to the 1/2 power or the square root of x, depending on what you're most comfortable with, we need to be able to get this to a whole value of x. So the easiest way to do that is just to simply square 1/2 by its inverse, which would be the second power, and do the same thing to both sides. And what you would get as a result is that x is equal to 16. So hopefully a relatively simple example just to kind of get you thinking about, hey, we can take these radical equations, something that has a different power than 1, and then find these solutions. So a second example that I want to look at is keep going along this route of rational exponents that we talked about previously. So in this type of situation, we want to do the same thing that we just did before. We want to separate out the rational exponent portion with just the constant values. So the first thing I'm going to do in this particular instance is that I want to get this rational exponent part all by itself. So that's pretty easy to do. If I divide both sides by 3, that gets me to that circumstance pretty quickly, because the 3's will cancel. 81 divided by 3 goes into 81 27 times. And then we can get this circumstance where x plus 3 to the 3/4 power is equal to 27. And then we can kind of progress through this and start figuring out what x is. And to figure out what x is, we have to have x to the first power. So again, what I want to do is I want to multiply this rational exponent here by its inverse. Okay, and just the definition of an inverse, if it's kind of escaping you, it's just the number that you multiply a number by in order to get 1. So if you take 3/4 and you multiply it by 4/3, you would get 1. So if this is your value, so to speak, and you multiply it by its inverse, this is what you need to get the value of 1. So what we're going to do is we're going to take the 3/4 power here, and we're going to multiply it by its inverse, because if we multiply these two values, this will give us x plus 3 to the first power. But then we also need to apply that to the 27 here. So whatever you do to one side of the equation, you have to do the exact same thing to the other side. Okay? And the end game here is, now that we've separated the rational and the constant portion, we have to go and then get this rational exponent to 1 so that we have x plus 3. And then with the 27 here, there's a couple different things you could do. Now that we've talked about rational exponents, you could actually plug this in your calculator. The other thing you can do is you understand that a of m over n power is equivalent to the nth root of a to the m power. So depending on how you want to set that up, we can go and set this apart and say that the cube root of 27 to the 4th power is what this is equal to. And I can see that, you know, there's 4 parts here, so we can pull 3 of them out here. And we could say the cube root of 27 cubed times the cube root of 27, which, mind you, is made up of 3 3's, which can be pulled out front. This can be pulled out front to give you 27 times 3, which is equal to 81. And we don't necessarily need to go through that. I'm comfortable with you using a calculator and the rational exponent feature on there. But then what this allows you to do is just say that x plus 3 is equal to 81. This is really the goal that we've set out to do, is to solve this radical equation with a rational exponent. We can just subtract 3 from both sides and find that x is equal to 78. And this is your solution. So again, just another circumstance, something that looks a little bit different than what you've maybe done before in this class or in Algebra 1, and a way to find a solution in this given circumstance. So let's talk about solving radical equations that could contain an extraneous solution. So it's probably been a while since we've talked about extraneous solutions. Extraneous solutions are solutions that you derive out of a specific equation, but may not actually be a solution to your equation. So let's talk about what we're doing and why this sometimes occurs. So the situation that we have here is that we have a square root radical. And one of the things that happens is sometimes, you know, with square root radicals, we have a situation where, you know, maybe negative numbers can't be applied. There are situations where, you know, you get 2 roots and things don't cancel out the way that they should. And part of that reasoning occurs is when you have x to 1 power here and you have x to a 2nd power here. So what you have to do whenever you're solving a radical equation like this, and if you have 2 separate x's and you can't separate the constant with the variable terms, in these situations you have to separate the radical parts that are different. So in this case we have a radical portion, and here we have a, so to speak, constant portion, or maybe the more appropriate term to use here is rational portion. And what we have to do in order to truly address this is we have to set these 2 pieces apart from each other. So we need this radical portion, this x plus 7, that's to the 1/2 power, separate from everything else. So to do that, we're just going to subtract 5 from both sides. That'll remove this component, and then we'll get the square root of x plus 7 equal to x minus 5. Okay, and then what this allows us to do is that once we have this circumstance, we need to be able to get these x's out of these radical formats. All right, so this x here, we have to get this out of here, and the only way to get it out of here is by multiplying the power of this square root by its index. So it's a 1/2 power. So we're going to square it. But because we did it to this side, we have to do it to the other side of the equation as well. And whenever you take the square of a square root, you always get the part that's in the inside. We don't have to do any special foiling or anything like that. It always comes out really nice. Now here though, x minus 5 squared is literally x minus 5 times x minus 5. So whenever this circumstance arises, we do have to FOIL this out and get our x squared minus 10x plus 25. And this will be equal to x plus 7. And now what I want to do in this particular circumstance is I want to use the zero product property so I can find my 2 solutions of x, because hey, I have a quadratic here now. So let's go and just move things around a little bit. Okay, cancel and cancel, and we'll get x squared minus 11x plus 18, all equal to 0, because it is an equation. And to solve for this radical equation that we started with here, we have to find the 2 possible solutions of x that are possible, and then we're going to check them. All right, and I'm looking at this particular instance, I'm going, all right, there's 1 and 18, there's 2 and 9. Ooh, there's 2 and 9, negative 2 and negative 9. And we can take these two factors, add them together, and see that we get negative 11. And we have two factors that we can factor out here. So this quadratic, if we go and separate it out, will be x minus 2 times x minus 9 is equal to 0. If you did forget how to factor this out, you always have the quadratic formula, but identifying those factors and factoring it out is going to make it much quicker for you. And with this, I can quickly see that my two possible solutions here is x equals 2 or 9. Really nice slick way to do this. But keep in mind that just because I derive these out doesn't mean both of these are true. We actually have to check it. And how you check it is by plugging it back in to the original equation here. So if we check, for example, 2 as a solution, let's plug in 2 and check it. Because they both could be true, one might be true. You might even get a situation where neither solution is true. All right, so if we go and we check this out and we plug 2 in for x, we get 2 plus 7 plus 5 is equal to 2. So let's check this out. If we see this, we're going to get the square root of 9 plus 5 is equal to 2. And what I'm going to tell you right now is that this simply doesn't work. 2 is an extraneous solution. And what you're going to notice is that if somehow the square root of 9 was a negative value, this would have worked. But since it wasn't, that was just kind of a situation that arises from the operations that we did. 2 is an extraneous solution. So now what we're going to do is, now that we know that 2 is extraneous, we're going to check 9. So if we check out 9, what we're going to see is 9 plus 7. We're going to add 5. We're going to set that equal to 9. We'll get the square root of 16 plus 5 is equal to 9. This will give us 4 plus 5 is equal to 9. 9 is equal to 9 last time I checked. And that means 9 is the only solution. All right? And that's how you check these radical equations and make sure that the solutions that you're finding are good. All right? So we found 2 and 9 as possibilities, but 9 was the only rational solution that worked for this radical equation. So one last example, another circumstance that you might see, just trying to give you a little bit of variety here, is you might try to solve an equation with 2 rational exponents. Now, we have a situation here, and this is very similar to the previous example, except both of them are underneath some nth root. And whenever you're dealing with this, the radical portion here is different, it's to the 1/2 power, than the power taken of the radical portion here. And these two cannot be on the same side. So a really easy way to do this is to just simply add this portion to both sides of the equation. So if we add 5 minus 2x to the 1/4 power to both sides, 5 minus 2x to the 1/4 power, we can very easily overcome the circumstance and separate the 2 different rational exponents for this particular problem. So the situation that we would get here is we'd have x plus 5 to the 1/2 power equal to 5 minus 2x to the 1/4 power. And now that we're in this situation, what we need to do is we need to get the rational exponents to equal some type of whole number. So the easiest way to do this is to just simply look and go, all right, like, what can I multiply 1/2 and 1/4 by in order to get some whole numbers? Well, I see that 2 goes in the 4 twice. So what I'm going to do here is I'm going to multiply both sides to the 4th power. Okay, and you probably remember from the previous lesson that if you go a to the nth power and you multiply it by the nth power, that this is the same as a to m to the n. So we're just taking that same relationship here, and I understand that if I go 1/4 times 4, that this is equal to 1, and if I go 1/2 times 4, this equals 2. And I'm okay with this, because what I'm going to have is I'm going to have x plus 5, and this is going to be squared. So I'm going to need to FOIL this out. But I get 5 minus 2x all by itself, and it's really simple and easy to deal with. Okay, so if I go and I FOIL out x plus 5 squared, I'll get x squared plus 10x plus 25. I'll set this equal to 5 minus 2x. And now I need to find the solutions. Okay, and the easiest way to do this, again, is to take advantage of the zero product property and start moving stuff over. Cancels, cancels. All right, and now what I'm going to get over here is, we'll just kind of meander it over here real quick. So we'll get x squared plus 12x plus 20 equals 0. And now I just need to find my solutions. And again, if you don't know how to find these solutions, you can always use the quadratic formula. You always have that in your tool bag. You can Google it if you need to see how that format is again. But the thing I notice here is if I go 2 times 10 and I add those together, 2 times 10 gives me 20, and 2 plus 10 gives me 12, which matches my b term here. So I can separate this out real quickly and just say, hey, x plus 2 times x plus 10 is all equal to 0. So that means my solutions for x are tentatively -2 and -10. And again, we can't take this as gospel and just run with it. We have to check it. All right, so if we see this given circumstance here, what I'm going to do is I'm going to go and check them. Okay, 1 might be good, 2 might be good, none of them might be good. All right, either one of those circumstances could arise. So let's check -2. So if I plug -2 back into the original expression here, I'm going to go -2 plus 5. Let's take this to the 1/2 power minus 5 minus 2 times -2 to the 1/4 power, and set this all equal to 0. So if we have this, you'll see that this is going to give me 3 square root minus, this will be -2 times -2, that'll be positive 4, so this will be 9 to the 1/4, which is equal to 0. What I will point out is if I simplify this out, this is 3 to the 1/2, and this is 9 is also equal to 3 squared, which if I multiply that by the 1/4 power, this will be 3 to the 1/2. 2 over 4 is also equal to 1/2, which will equal 0. And what you'll see is that this solution will work. So -2 is a real solution. Okay, and one thing that I want to point out is I always want to put -2 back in the original equation, because I don't want to start here or here and start checking it that way, because if I did a mathematical operation incorrectly right from the start, obviously that's going to work, right? So I always want to check it back in the original equation that I used. So now let's check -10 and see if that comes out the way I expect it to. So if I plug in -10 here, I'm going to do the same thing. Let's take a little bit of a shortcut here since I'm running out of space. -10 plus 5 will be -5 to the 1/2 power. Okay, and let's go one step further and say -5 times -2, or -10, I'm sorry, times -2, which would be positive 20, and 5, this will be 25 to the 1/4 power, all equal to 0. And one thing I want to point out here is, even though we're dealing with rational exponents here, this is still a problem. This is still imaginary. making -10 an extraneous solution, making -2 the only real solution. So with that said, I hope you have a better understanding of how to solve radical equations and how to approach some of these different circumstances. And with that said, let's do some math.